Okay, this is probably the one video that you're going to watch more than once. What I'm going to do is I've outlined already, but I'll talk through this. This is a 5-step method that I want you to use to solve all your hypothesis testing problems. Now, when you first look at it, I'll step out of the way so you can see everything. There's a lot up here. But once I step you through it, and then we work some problems, it shouldn't be that bad. So let's look up here at the first thing we have, step 1. And this is called H naught, H with a subscript of 0. That's the null hypothesis. H with a subscript of 1, that is called the alternate hypothesis. Now, sometimes the alternate hypothesis will have a subscript of 1 instead of A. Well, here I got 1. Sometimes I have an A instead of 1. So you may see either one. The null always has a subscript of 0. Now, what are these? Well, the null hypothesis is what's believed to be true. Ah, shoot, that marker's not working. Let me get another one. Okay, that is something that is believed to be true. It's a published number. It is an established claim. For example, suppose you watch a football game. Let's hope we have football this fall. But you watch a football game and the car commercial comes on. You get 38 miles to the gallon. Maybe it does, maybe it doesn't. But they establish that as a claim. What you have to do, if you buy one of those cars and you're not getting what they're saying, then you're coming up with the alternate hypothesis. No, that car does not get 30 miles to the gallon. This is a challenge to the claim. This is a challenge. This is what you want to prove. It is not currently proven. It's what you want to prove. Now, let me talk about step 1. In reality, step 1 is the easiest step on this list here. Because if you got a problem you want to do, you know the problem. Suppose you're solving a problem for somebody else. Well, just ask them what it is. They'll tell you. They'll tell you what step 1 is. However, you're not fortunate like that. You're in a classroom. And in a classroom, these authors write these questions all kind of different ways. Sometimes it's very difficult to figure out what the null and alternate hypothesis is based on how the way the author writes the question. I would try to be very clear when I write questions for you what the null and alternate hypothesis is. Can't promise, but I'll try. Reading from a textbook, this is the hardest thing to do. In reality, is probably the easiest. Okay, let's look at step 2. Step 2 is clerical work. You're just going to talk about the problem. You're going to state the test performed. Now, we're going to know 2 tests. We're going to either work with a z-test or a t-test. Now, when I say z and t, that goes exactly along with a confidence interval with the t critical value and a confidence interval with a z critical value. For the same reasons we use a t or a z critical value with confidence intervals is the same reason we'll use a t or z statistic here in step 3. Also, up here, I want you to tell me how many tails it has. Is it a 1-tail test? Are we only looking at the bottom tail? Are we looking at the top tail? Are we looking at either tail, which would mean a 2-tail test? And I'm sure I'm saying a lot of things right now that doesn't make a whole lot of sense. That's why I'm saying that once we work a problem or two, you probably come back to this video once you work a problem or two and realize that's what he meant. So let's hope that does happen in the future. Now, 2B, state the alpha level you're using, this level of significance. I've used the word level of significance before. I've used the letter alpha before. I used alpha over 2 when I was talking about confidence intervals. We're going to treat it as alpha when it's a 1-tail test, alpha over 2 when it's a 2-tail test. We got to chop it in half when it's a 2-tail test. State the degrees of freedom. We had to find the degrees of freedom, so we get to find our t critical value. All we do is state the degrees of freedom. Now, if we're doing a z-test, the degrees of freedom are infinity. If it's a z-test, the degrees of freedom will be infinity. If it's a t-test, it'll be a number less than 30. 30 or less. 30 can be 30 is on the chart also. State the rejection region. That is going to come off the t-table. The t-table that you learned how to read for the confidence intervals. That is exactly the table we use to do this. Test statistic is either going to be one of these two forms here. Z equals x minus mu over sigma over the square root of n, which I've already shown in the last video. Or if you're working a t-test, it's x minus, x minus mu over s over the square root of n. The difference here is you have population standard deviation versus sample standard deviation. Now, here's something that I'm kind of picky on, are step 4 and 5. Step 4 and 5 are where you write your conclusion. Now, let's go ahead and put a normal distribution up. Suppose our cutoff is, that's our cutoff right there. We're doing a one-tailed lower tailed test. And our test statistic that we compute here in step 3 lands right there. What that means is that's outside the confidence interval. That's not realistic. So what do? We reject the null hypothesis. If our test statistic, however, falls inside the confidence interval, then we fail to reject. We did not have evidence. Our sample was not really, really different. If it lands in a rejection region, we will reject the null hypothesis. If it doesn't, like this one, we will fail to reject. This will always have H naught in it. H naught will always be the hypothesis that is mentioned in step 4. In step 5, the alternate hypothesis will be the hypothesis mentioned. And based on this, if you fail to reject the null hypothesis, then there was not evidence to accept H1. But if you did reject the null hypothesis, there was evidence to accept the alternate hypothesis. If you reject this, you accept this. If you don't reject this, then there was not evidence to reject it. That's what's going on here. So those are the 5 steps that we're going to use. And I'm sure feel free to play this video over and over and over, because I'm going to get some problems. We'll work some problems here in just a moment, and that'll be my next video. And all these words will be erased, and I'll actually start putting numbers in it. See you in the next video.